Hey guys, let's get started. What will you need to do proper soldering? That would be tools. A soldering iron. This is a cheap make in South Africa. No name, to be honest. This is what I've been using for quite a couple of years. Not using it anymore, but I'll just be using this to explain. Anyone would do. Any soldering iron, as long as you look after your tip and it's not too powerful, it'll work for electronics. Lower wattage or power rating is better. Smaller soldering task obviously is for small tasks between 1 and 2.5 millimeter tip, in other words as fine as possible. You're looking for a what they call a chisel tip, not so much a conical tip, but you can get by with that as well. Large soldering tasks, well, that is not for electronics, so I'm not even going to bother covering that. One thing I would note, if you have damaged or corroded tips, like you'll see, I'm not sure if it's going to focus on the camera though, there's some dings in this one, obviously with use, replace them. Bad tips results in bad joints. That's it for a soldering iron. After that, you would need a soldering stand. This is mine. It used to be my go-to soldering stand. It's basically a metal coil. You insert the soldering iron right here. It keeps it off the table so you don't burn the place down. As you see, this is something I just made myself. It's nothing fancy. You get lots of fancy ones, but I think this is 35 bucks or something like that. Not much more I can say about that. Excuse me. Then you will need a damp sponge. Any sponge will do. As you can see, this thing has been used a lot. What you would do with this is just to wipe your tip. Damp to have the excess solder solidify once you sort it off. That's it. Then you would need one of these babies, a third hand as it's called, helping hand, some people have known to call them. What I would say, you'll see I've removed this from my other old stand. If you're crimping one of these or your PC board, take care not to do damage. If you do damage, you're going to have to redo your work. You might wreck the component. So it's a normal piece of packing sponge, anti-static. You get in most packages if you buy electronic stuff. You can also obviously opt for a friend's hand. If you don't have one of these, just take note, it's going to get hot. Then the bird of contention, I think, soldering iron, soldering wire. As you can see, this is very thin, 0.7 millimeters. This is what I use. I don't use anything thicker than this. For electronics, I have a small method I've devised way back. If I want to solder something, like a transistor for instance, my soldering would be as close as possible to the same width. Why? I do not want to flood the poor thing with soldering and battle to get it off later. This is a resin core. Resin core being, once the moment it melts, it releases flux, which helps with the bonding obviously. Try to get a 60% tin by 40% lead, which this is. That works the best, in my opinion. You get different ratios. You get up to 80 to 20. I believe you even get lead-free soldering wire these days. But it's not worth it. For where we're at, and I'm talking about the novice like myself, you need all the help you can get. So the more lead you can have in there, the better. Don't worry about the lead poisoning thing, please. There's people that's been working with these things for donkey's years and they're not dead yet. So that's a myth, in my opinion. And someone can flame me about that, thank you very much, but I still said it. That's it. That's what we need for tools. Right, now let's get to preparations. Your soldering iron, as I showed, you need a clean tip. So this is the one I'll be using to show you. It's easy. You need your tip tinned. So what is thinning? It's easy. Take some soldering. It's a hot iron. You melt some on it. Don't inhale the smoke. Please don't inhale the smoke. That is poisonous and it will kill you. So what does that do? Well, you can see the droplet, I think. That droplet. That'll cause your iron to have a thin layer of soldering on it, which will help with heat transfer, and it will also help protect your tip. Forgive me about that one. That's your soldering iron. Wire joints, once again, you need these things to be clean. Clean, as in clean. No corrosion, no nothing. If you have a piece of wire you want to solder and it's got corrosion on it, my advice would be chuck it, get a new piece. You clean it up and you tin it. So for tinning it, use the packing, stick it in your crocodile clamp, and here you want just a bare piece of wire that's been exposed. I've got a few hints here that I need you guys to look at. Number one, I've got a small tip, so it's going to take a while to heat up. It's quite a thick piece of wire. You want to heat your wire from beneath. When do you know it's hot enough? Oh, that's a good question. You put your soldering wire on top, and it should show you when the heat is at the right spot. Come on. Aish. Come on. Just set up this thing a bit. It's a bit on the slow side now. Let's try again. It's tinned. What you could do is something that I saw on YouTube. It's while hot, just flick it to clean it up. And while I'm busy with this, let's just do another wire so we can do some joining for you guys later. Come on. Once again, I wrote it. I want a nice neat joint. My preferred method of joining obviously is a lap joint, like in the woodworking lap joint, not like in a lap dance. I believe in tinning before I solder. I don't want excessive heat on my components, which means I cannot afford to twist this oak and then have it be difficult to get the solder to stick. So obviously this is a little bit on the hot side. A few things to note. There's no tip sticking out. Why? It's going to just leave you with an ugly joint, for number one. For number two, it might pierce your heat shrink if you shrink your joint, which you should be doing. Number two, do not melt the isolation. That will be bad. If you do that, get a new piece of wire, snip it off, clean it off, and start again. That is the best way to do it, my opinion. Take your packing tape again, and we'll somehow do the joint, which I wasn't supposed to do now, but I will do now. So this can be your friend's hands. Just take note, it's going to get hot, so get a beefy friend. Right, what you want to do is you want to get these wires to be touching each other and aligned properly. Why? Because this is going to be quick and dirty. The moment you touch the wire, it'll melt the solder that's already on your wire, the tin, and then you just fill in and you leave until it cools down. once cooled, now this is a sloppy joint. Doing it for a camera is a bit difficult, but it's still a decent joint. Things to note about this joint though. This is a connection, electrical connection. This is not a mechanical connection, so don't try hanging your car from it. It won't hold. That's why I don't believe in tying my wires. I do not want to hang a car from it. I just want an electrical connection. I don't care what people say out there. I've been doing this for years and years and years, and I've never had one fail. That's it. Let's move on. That was wiring. From here we want to go to boards. So on boards, here I have a nice and shiny piece of board, which I used to be from. And just to show you what clean means, this is an old one, and if I have time on this video I will show you what it looks like and the effort you have to go through to get something to stick to this board. Clean it. Fine sandpaper, clean your copper contacts, or a quick tip. Don't use it always, but in a pinch a normal eraser will also clean it. It's going to wreck your eraser, but yeah. So to get this done, once again, you don't want to stick your the crocodile clamp directly to your board. It's going to wreck it. This is a piece of board, so it's not really that delicate, but on a properly manufactured board it will wreck your copper clad. So I'm going to use a normal IC holder. Why? Because I can get this thing to stick quickly. And this is the biggest problem in soldering, in electronics, is to get the component to stick properly. Once again, let me show you. You take your bit, your tip of your soldering iron, nice and clean. I just wiped it on my sponge. Stick it on the board and touch the pin. You're going to wait a few seconds. You want the pin to heat up, you want the board to heat up. Never ever on the board touch your soldering iron with the wire. Touch the component and the board, and done. And I mean done. That is done. I don't think you will be able to see it on the camera. I will try and get a close-up still, and I will embed it into this video for you guys to see. What I could do is I can maybe draw a picture of what I'm expecting to see here, what we expect to see. Let me just get a piece of paper here. What do I mean by what do I expect to see? Quick. That's your board. This is a section of your board. Oh, and I think this is going to be a long way around for you guys, but take note. Your copper clad is going to sit on one side, and with double-sided boards obviously you're going to have on the other side as well. And I'm raising that point because there's some important thing you need to note about that. That's your copper, and I know it's a bit overscaled, please forgive me. This will be your component lead, attached to some funky resistor or something. Doesn't matter. When you solder this out, you don't want this being soldered. That is not a proper joint. What you want is you want a nice concave, shiny solder joint. So if you look at this thing from the top, you're going to see the leg, and you're going to see a pool of solder concave. What does that tell me? That tells me that the component's leg, lead, and the copper clad both had the right temperature, meaning the moment I touched my soldering wire to it, it flowed. And once you start doing this on a regular basis, you will understand what I mean by flowing. It is, I've heard somewhere on YouTube people say that the solder has an affinity for the hot area. That is so true. The thing is, remember your soldering iron tip is the hottest thing around. You need the component lead and the copper clad to be that. That's why You come in from the one side with your tip, you heat up both of these components at the same time, and then you enter from this side with your solder. That means the moment you touch here, it melts and it flows around, closing this out. A bad joint will leave you with some, let's call it, blobs sitting all over the shop and show. Clean it off, remove it. It's not gonna, that's where what they call cold solder joints hide. It looks like it's properly connected, but it might not be. The copper clad might not have been up to temperature, which means that bead of solder is stuck to the component lead, but not properly stuck to the lead. A little bit of vibration, it's going to become loose, and you're going to have a circuit not working. With a double-sided board, remember, you're entering from this side. With a double-sided board, when you're done, you would want that same kind of look, but on a smaller scale, on that side. What does that say? That said that your soldering wicked its way through. Remember, it's going for all the hot areas. Because this is a double-sided board, this will be what they call a via. It's like a small metal tube that's been goes right through the board. So it's going to draw in the solder. You're going to have to add a little bit of more solder. That's making it very overly complicated in any case. What you're looking for is a nice concave, shiny joint. That's it. What else do I need to tell you? Precautions. Well, let's first go to notes. Something I need you guys to note. Take better care of this than you take care of your lunch. It needs to be clean, 100% clean. Whatever you put on this, like my fingers that's full of sweat at the moment, is going to leave oxidation on the alloy. You need to clean that off because that is contaminating your joint. Bad, very bad. You'll see my wrapping is still on here. It's still on here. Reason for that, I try to keep this isolated from everything. Better than your lunch. Remember, that's a soldering iron. If you can see that, it's bluing, meaning this is standing on and I'm not using it. What am I going to do to protect this when I'm done? We just stick some solder on there. In other words, we tin it again, we wipe it off on the sponge. Now it's nice and clean, it's nice and shiny. Put it in its stand and switch off the soldering iron. It won't blue, it's going to protect your tip. That is on the notes. Oh yeah, and please keep these things clean. These and these. Trust me, I've tried soldering dirty, corroded wires. Not worth it. Chuck it. Get new ones. By the way, your component should not be in a corroded state. That means you didn't look after it, and you must expect headaches, because that is bad. Okay? Cool. Precautions. And I have to say this because this is going to go out in public. Do not breathe in the fumes, please. It's bad for you, it is poisonous, and you will get sick. This is no joke. There's lots of very bad chemicals in these things, apart from the fact that most of the times novice electronics hobbyists tend to stick their solder irons places where it shouldn't go. So it gets full of gunk. Bad for you. Use safety glasses, well, or some of these. Why? As you saw me flick the wire earlier, that is a hot ball of melted lead tin alloy that's going to come flying at you at 300 plus degrees Celsius. Trust me, it's going to wreck your eyes. You're going to be very sorry. Keep yourself safe. Do not touch the iron. As I said, it's plus minus 300 degrees. In some cases, like my iron, I set it up just for these wires at 400 degrees. It's going to leave you with a very nice blister. Do not leave your hot soldering iron unattended. I mean, I should not be having to ask you to look after your stuff. Most of us have kids in the house, pets and the like. It takes 1 second for a soldering iron to get knocked off the table and you burn your house down. Don't do that. Unplug your devices. That sounds like a stupid thing, but I've seen this before. Imagine, just for a second, I've got this nice ping sensor, which you all know. I want to solder a pin here, but it's plugged to my Arduino or microcontroller. What do you think is going to happen if I touch this thing while it's powered? Not much, you say. Well, let's correct that situation. Every modern soldering iron, like this one, has got a voltage on the tip. And I can prove it, but I'm not going to do that now because I don't want to wreck anything. If you solder LEDs, if you're busy with the cathode and you're not properly grounded, you will see the LED glow a little bit when you solder it. That is because there is a voltage on this tip. It's not a very big voltage, but it is a voltage. If this thing is powered and there's 5 volts on this thing, and you touch it with this thing, you're going to either short this one, or you're going to chase the 5 volt up this one. Neither of which is going to be good, so don't do it. Unplug your boards. I don't think I have to tell anybody to do that, but just in case. Remember, soldering is not welding. It's electrical connections, not mechanical connections. So don't expect a soldering joint to keep your microcontroller hanging on your butt or whatever. It's not going to last. This is not supposed to have tension on it. It's just a wire. Okay. That is it from my side. If you have any questions, please post them in the comments and I will get back to you. And if you want to tell me I don't know what the hell I'm talking about, you can do that too. I will appreciate any feedback. At least it means someone's looking at this. And for those who actually got to learn something, yay, go get some of these, very cheap, and get a handful of IC holders or whatever, and practice some. And if you have some issues, ask me and I can see if I can help you. Thank you very much.